This is lesson 3.2, properties of exponents. If I give you 7 to the power of 5, we know that that's the same as 7 times 7 times 7 times 7 times 7. I also could write that using my associative property. So if I go 7 times 7 times 7 times 7 times 7, notice I have the same amount of 7s. That's 7 to the third power times 7 to the second power, which still gives me 7 to the fifth power because I still have 1, 2, 3, 4, 5, 7s. Or I could write it as 7 times 7 times 7 times 7 in parentheses, and then times another 7. That's going to give me 7 to the fourth times 7 to the first. And again, I still have 5 7s, so it's 7 to the fifth power. So ask yourself, what are we doing with these exponents? We're having the same base, they're all 7s. What do we do to get the exponents? 3 and 2 give us 5. 4 and 1 give us 5, but it's if we add them. So that takes us to this property right here, multiplying powers with the same base. If you multiply powers with the same base, you keep the base and you add the exponents. They're giving us the example 3 to the 5th times 3 to the 8th, same base. You keep the base and you add the exponents, so it's 3 to the 13th. Let's look at this example up here. I have 2 to the 3rd times 2 to the 4th. I keep the 2's, and 3 plus 4 is 7. So this is 2 to the 7th. Here's our rule. B to the m times b to the n is b, you keep the base, and you add the m and the n. You add the exponents. So let's do a few here. 5 to the 4th times 5 to the 3rd is just 5 to the 4 plus 3, 7. You don't even have to have numbers. You can have bases that are variables. A to the 12th times a to the 12th. I keep the a. 12 plus 12 is 24. 16, if they don't give us an exponent, it is 1. It's not 0, because remember, anything to the 0 power is just 1 anyways. So 16 to the 1 times 16 to the negative 7 gives me 16. 1 plus negative 7 is negative 6. So it's 16 to the negative 6th. Oh, well here I have 4 squared times 3 squared. I do not have the same base, so I can't use a shortcut on this. I have to just go, oh, 4 squared, that's 16, times 3 squared is 9, and then I work out 16 times 9, which happens to be 144. So be careful. If they do not give you the same base, you cannot use that shortcut. Okay, next let's look at some division. So if I have 5 to the 7, that's 7 5s. Divided by 5 to the 3rd, that's 3 5s. And I can cross off the common factors here. So I can cross off 3 sets, and that gives me 1, 2, 3, 4, 5, so this is 5 to the 4th. If I have 10 a's, or a to the 10th, there's 1, 2, 3, I think I have 10 there, over a to the 7th. And so I can cross off the 7. sure we know that one's crossed off. And that gives me 3 of them, so it's a to the third. Again, let's look. We have the same bases. What's the connection between the 7 and the 3 to give me the 4? And the 10 and the 7 to give me the 3. That's right, it's subtraction. So the next property says to divide powers with the same base, keep the base and subtract the exponents. So 6 to the 9 over 6 to the 4 is 6 to the 9 minus 4, or 6 to the 5th. And here it is algebraically. B to the m over b to the n is b, we keep the base, and m minus n. Let's look at a couple of these. I have 10 to the 8th over 10 to the 5th. It's 10, I keep the base, 8 minus 5 is 3. And x to the 4th over x to the 9th is x to the 4 minus 9 is negative 5. And we can keep it as a negative exponent unless they tell us to simplify it. Okay. Next, let's see what we have happen when we have this. I have 4 to the 3rd power raised to the 2nd power. So this tells me there's 2 copies of 4 to the 3rd. So this is 4 to the 3rd times 4 to the 3rd, which we know is 4. We're going to use this property back here. So we're going to keep the base and add the exponent, so it's 4 to the 6th. And this is 5 to the 4th, but I have 3 copies of that. So 5 to the 4th, 5 to the 4th, and 5 to the 4th. It doesn't matter if I have 3 factors here. I'm going to keep the base as long as it's the same. And 4 plus 4 plus 4 is 12. So let's see if we can make the connection here. I have 4 to the 3rd power to the 2nd, and I come up with 4 to the 6th. I have 5 to the 4th power to the 3rd, and I come up with 5 to the 12th. So what are we doing with the 3 and the 2 to get the 6, and the 4 and 3 to get the 12? That's right, you multiply. So here it says to raise a power to a power. Keep the base and multiply the exponents. So 9 to the 4th to the 5th, I keep the 9, and 4 times 5 is 20. Again, algebraically, b to the m to the n is b to the m times n. So let's look at this. I have 7 to the 5th to the 3rd. 5 times 3 is 15, so 7 to the 15th. 8 to the 9th to the 11th is keep the base 8. 9 times 11 is 99. Big number. 2 to the negative 7th to the negative 2nd. Negative 7 times negative 2 gives me 2 to the positive 14. So I can have negatives that turn out to be positives when I'm multiplying here. And x to the 10th to the negative 6. 10 times negative 6 is negative 60. So x to the negative 60th power. Alright, let's do a couple story problems here, and then I'll give you your assignment if you want to get started tonight. Jefferson High School has a student body of 6 to the 4th students. I know we don't normally talk that way, but they're just going to give it to us that way instead of telling us how many students that is. Each class has approximately 6 to the 2nd students. How many classes does the school have? Right, the answer is 1 power. So the student body, there's this many students, 6 to the 4th. Each class has 6 to the 2nd, so I'm going to divide 6 to the 2nd. And when I divide, that's going to tell me how many classes it has. Total students divided by students per class. So this is going to give me, remember when you're dividing, you keep the base and you subtract the exponents. So it says, right, the answer is 1 power. So it's 6 to the 2nd power, and we would say that that's 6 to the second classes, which we know is 36 classes, but they're asking us to write it as a power. Okay, 29. It says write the expression for a number used as a factor 15 times. So number used as a factor 15 times, so some number to the 15th power, multiplied by a number used as a factor 10 times. So we're going to have to say that the number is the same number. Otherwise, we can't really do this with our shortcut. So 10 times. So I know if I have the same base, I keep the base and I add the exponents. So a to the 25th power is the final answer because 15 plus 10 is 25. Alright, I know it's Halloween and you probably don't feel like getting started with this assignment, but if you do decide to get started, I will go ahead and give you the pages. This is lesson 3.2 and it's going to be page lost my place here, sorry. Page 98 to 99. And I'm going to have you do problems 2 to 38 even. And then 49 and 50. Well, hold on. I'm going to change that. Sorry, you can grumble and complain at me because I can't hear you, so it's okay. Let's do 2 to 44 even. So that's only 22 problems right there. And then I want you to do 45. And 49 and 50. Okay, again, this is optional because you will have time to work on it the whole class time tomorrow after we're done checking lesson 3.1.